The objective today is to use developer tools in a modern browser to explore the HTTP traffic of common websites. I'll be using the Chrome browser, which I should suggest you do as well. Today's lesson is pretty short, however, the activity you can take as long as you'd like with it. So we're rounding out our understanding of how many protocols and systems of the internet work together to make the internet function. We want to think of the protocols as working in layers. You've come to know this as abstractions. Imagine outgoing information going down the stack and incoming information going up the stack. What stack? Okay, I'll talk about that in the next slide. But all of this happens in the network software on each computer. So whether the computer is your phone, a laptop, or a server like a DNS or web server, routers are a special case that only look at the IP layer. Regardless of what type of computer we're looking at, that communication, that relationship still exists. When you're having outgoing information, it goes down the stack. Incoming information will be coming up. So think of that down and up relationship. And here you go, a better visual for you to understand this with. I should start by saying, in this example, imagine this cell phone is in your hand and you have incoming bits being sent to you. So maybe a friend over across the room sends you a text. So here come the bits into your phone. The Think Right Share says use a stack diagram to write a descriptive paragraph detailing each step. So incoming bits, the physical internet receives bits and assemble it into packets. All right, so physical internet being a wire or Wi-Fi, okay, sending a radio signal through the air. That signal is showing ones and zeros. That's what I mean by incoming bits. So receive bits, assemble into packets, hand off to the IP. The IP reads and groups packets based on from, to, and from addresses. Then it gets handed off to the TCP software, okay? So TCP puts packets in order and reassembles a message. And then there's a handoff to the DNS. It reads and handles the DNS response, okay? So once that response is handled, here we go. The bits make a DNS request. This gets handed off to the TCP protocol, breaks it into packets, then hand off to the IP, so it checks the to and from addresses, and then sends the bits to a local router. That way the router can figure out where to send that data after that. So using this image, this is basically computer networking, okay? Physical internet, then you have one layer, the IP, and another layer, TCP, and another layer, DNS, and that's how information gets sent around, okay? The important takeaway here is to understand that the system was constructed with layers of abstraction where each layer only needs to concern itself with its specific job, and then hands it off to another layer. This makes the very complicated task of digital network communication possible. At the top layer, for example, DNS just thinks it's speaking DNS to other computers. The DNS protocol does not even need to know how the other layers work. It just relies on them doing their job. If those layers don't do their job, DNS cannot do its job. This concept applies to both humans and hardware. We do not need to know everything. That's rough to say, especially if your personality is like me. But if you're still a little murky on this whole process, it's okay. Just take a deep breath. Remember that there's layers, that things work in these layers, and you should be good to go. So here's an exam practice question. I thought we should do these once in a while. HTTP is considered to be a high-level protocol because A, HTTP requests are given higher priority for fast delivery when being routed on the internet. B, HTTP requests are encoded using higher frequency radio waves. C, HTTP messages can be either requests or responses. Or D, HTTP requests make use of abstractions provided by lower level protocols. Choose two. Choose the two statements about HTTP. And from what I understand, you can have a question like this on the AP test where there's two things that you need to select. So, what two are true? A, an HTTP request is sent from a client to a request access to data stored on a server. B, HTTP requests and responses have identical formats. C, displaying a web page will often require multiple HTTP requests in order to acquire all the necessary data. Or D, An HTTP response code is only used when a server could not fulfill a request. So we're actually going to talk a little bit more about C today. Displaying a web page will often require multiple HTTP requests in order to acquire all the necessary data. So if you go to this link right here, we're going to use something called Developer Tools to look at HTTP requests and actually look at the data that comes from these requests. So go ahead, navigate to the developer tools on your browser. You'll use your browser's tools to discover what kind of HTTP traffic is associated with visiting different websites. So you have 1, 2, 3, 4, 5 here. I want you to check out each type of these websites, okay? I'll go ahead and do that with you here. So once I type in this link, I go somewhere that looks like this. This is great information for you to read. Basically, though, it says select the 3 lines on your browser and click Developer Tools. So if your browser looks like mine, you go over here to the 3 dots, not lines, go down to More Tools, select Developer Tools. And this pops up. And this is going to be intense, okay? So now if I go to the URL, I can change it to, let's say, cnn.com. When I push enter, I'm going to be able to see all the data coming in. So here, down here, is the HTTP. It says get and a website. And okay, down here, it's going to show the errors. So the school is going to block many different things. You can see here on Amazon, there's some sort of ad thing the school is blocking. There's nativesharethrough.com. That's, I don't know, a lot of these things I look at, I just don't know what they are. You can spend, I think, hours in your day just looking at this stuff. Oh, and look, it says, uh-oh, looks like you're using an ad blocker. Okay, so if it's not the schools, they're probably upset about my ad blocker up here, which apparently has blocked 13 items. So here's CNN.com. Here was all the traffic, all the data that came with it. And it's cool to look at the type of data. So there was some information about the font. Here's some scripts. Scripting being like the behavior of a website. That's usually what this is about. A document. Documents are more like the content, okay? Sometimes if you click on things, you can learn more about them. Let's see. There you go. So you can see the code behind that script. X right here to get us back to where we were. So yeah, just so much to look at. You can see there's images here, different types of images. You'll learn more about files later, so you can understand more about this type here. But this is my favorite column type, actually. The time column is interesting. 7.61. It's got to be like milliseconds. There you go, milliseconds. Oh, and then 2.18 seconds. That's an entire second. That's quite a long time. You can click the different things here. Like, there's just plenty for you to click on. Let's go to another website and see what happens. Another favorite of mine, ESPN. So this whole thing will start fresh. And here's all the data you can check out. So here's the HTTP requests being blocked down here. Starting at the top, first thing we got was text. Alright, let's try one more website together here in the video, and then you can go off and check out whatever websites you want. I'm going to go to Wikipedia. Watch what happens when we go to Wikipedia. Okay, that's it. That's it. That's the only data. Fascinating. So simple. I love Wikipedia. So as you're doing that, my think, write, share is simply observe things like A, the total amount of data received, B, the number of HTTP requests actually generated by loading one page. For B, you can also talk about what's being blocked. C, total time to load the page. And D, types of data received through HTTP. It's more than just HTML, so much more. Make notes about any questions you have or things that are interesting and worth sharing with others, and I'll be able to read that on Canvas as well as your peers. Here's another great visualization to look at. What happened in step 3 is my question. The Think Right Share says, what does TCP do to correct a missing piece of data? So something happens in step 3, TCP is going to correct it. So here's the transmitter on the right hand side, this is the receiver. So let's say you go to a website, okay, and that website sends you the number 1. Then you send back, okay, got number 1. The website sends you number 2, okay, got it. Website sends you number 3, but something happened, it never made it. Question mark, you did not say okay. The website's still going. The website's going to send you number 4. You're going to say, okay, I got 4. And then, since time has expired, the website didn't hear back from you, okay? It's going to resend that thing that it sent. Since it didn't get a confirmation, it'll go ahead and send it, and now you have the entire packet. Great video. And very short. In the video, the guy talks about different types of SSL. He talks about sites over HTTPS and how they will improve by using that S. That will improve your ranking on Google. Purchasing an SSL certificate. So my challenge to you is, what is a certificate? He talks about SHA-2 or 256. 256. Talks about green bar status. Self-sign is not a good idea. All right, if you have forgotten, we do technically have a textbook for this class, and you can find that book by going here. I think in my video series, I'll do a pretty good job at pulling out all the details that are the most important. And then for you who just love your textbooks, I'm giving you the link right there. So, DOL, what surprised you about the HTTP traffic you observed today?